Learning about our substitution rule. This is also known as U-sub. It's an integration technique that really helps us find the more complex antiderivatives. So here's the rule right here. So if we have a function inside of a function times the derivative of that inside function dx, we can actually substitute it out with the letter u to make it f of u du. Okay, kind of looks a little complicated. I'll break it down for you. So here are some guidelines for U-sub, and you can kind of read through this on your own because I'm really going to tackle this problem, and I'll refer back to this as I can. So for U-sub, what you want to do is look for an inside function. You want to look for something that's on the inside of something. Okay, and what's going to end up happening here is you're going to take the derivative of that inside function, and that's what's going to kind of happen right here. So step one, let's go ahead and look for that inside function. So I'm going to tell you right now, it's inside of cosine. So inside of cosine is going to be u equals x to the fourth plus 2. Now we got to take the derivative of this. Okay, so we're going to get du over dx is equal to, derivative of x to the fourth is 4x to the third. Now what I want to do is I need this right here, my side work, to look like dx and x to the third, because those are the only things I haven't touched yet. It's because I want to get rid of x to the third and this dx. So how can I do that? Well, I can just multiply that dx over. So 4x to the third dx. Almost there, but what do I have to do? I have to get rid of this 4 onto the other side. So I'm going to go 1/4 du equals x to the third dx. So now I can take my x to the third dx and replace it with 1/4 du. So let's go ahead and do that. So this x to the third dx is gone, right? And I'm replacing it with a 1/4 du. I'm leaving space, and you'll see why in a second. And then I didn't touch cosine, so cosine is still there. And then the inside, remember, I substituted that out. So that's just cosine of u. And the whole reason I do this is now this is a much easier function to take antiderivative of. So now what's the antiderivative of 1/4 cosine u? Well, if you want to, you can just put that 1/4 right on the outside and just tag along until the very end. Okay, so what is the antiderivative of cosine of u? It's going to be sine of u. So it's going to be 1/4 sine of u plus c. Now, since your question started in x's, your answer has to end up in x's as well. So we're going to take that u and substitute back in our original, which is 1/4 sine of not u, but x to the fourth plus 2. Don't forget our lovely plus c. And that is our first u substitution. Okay, so again, if you're looking at these steps right here and trying to match it up, look for your composition right here to substitute out. Take the derivative, replace everything that you haven't, that's kind of our mess in there, everything that we haven't substituted in. You're going to get this right here, take the antiderivative, and then plug that x back in. Okay, let's go ahead and do a couple more. Some of them come in obvious, some of them not so much. So looking at this first example at the top right here, what's kind of an obvious, ooh, this is an inside function, because if you notice, you have an x you could pick. You could pick a root 1 minus 4x squared, or you can just pick 1 minus 4x squared. So there's lots of choices right there. And then again, you want to pick something that's inside of the function. So 1 minus 4x squared is inside of a square root, so that's probably a good try. And it's totally possible that it might not work out, and that's okay. You're just going to try something different then. So when I take the derivative of this, I'm going to get du over dx equals negative 8x. So du is going to equal negative 8x dx. Now I'm just going to give you a heads up. Typically when people do U substitution, they kind of skip this middle step. They'll just put du on the one side and then the dx on the other side, and that's totally okay. Nothing wrong with that. Okay, so I do have an x dx up here, by the way. So what I'm going to do to get rid of it, because I'm doing a U-sub, I need to get rid of all of my other x's. That includes my x and my dx. So I'm on the right track here. I'm going to divide by 1/8, or sorry, multiply by 1/8 on the other side. to get x dx. So now my x dx goes away. It becomes negative 1/8. You don't mind if that negative 1/8 on the outside. And then that dx turns into a du. So I'm going to get 1 over root u du. So there's my substitution. Now, I think it's a little bit easier if we just rewrite this guy to be u to the negative 1/2. Because now I can use my reverse power rule a little bit easier. So I'm going to add 1 to that. So I'm going to get u to the 1/2. And I'm going to divide that by 1/2. And it's negative 1/8 times that plus c. Let's do a little bit of cleaning up. I'm going to get negative 1/4 u to the 1/2 plus c. And when I substitute back in my original here, I'm going to get negative 1/4 1 minus 4x squared 1/2 plus c, which if I rewrite this with a square root in it, it looks like this. Okay? And remember, if you were to take the derivative of this, you would have to use chain rule, but you would end up with this as your answer. Okay? So the next example. So it's going to let you know right now it's going to get a little bit tougher to figure out what is what. Okay, so our u here, again, you have a couple options. You can do sine, cosine, or even sine to the third. You can try all of those, but only one of them is actually going to work out. Okay, so what's inside usually the most complex function here? Well, that cubed is really messing everything up. So what if I just got rid of the sine? What if I let u equal sine of x, which means I now need to get rid of cosine x dx? Well, that's fine because the derivative of sine is going to be cosine. Again, I skipped this middle step right here. I just put the dx on the other side. I hope you're okay with that. So now cosine x dx goes away, and that just becomes du. And that sine turns into a u to the third. So I'm going to end up with 1/4 u to the 4th plus c. So this one looked pretty gosh darn complicated. It really turned out being not so bad. Just replace this back in now. So 1/4 sine 4th of x plus c. And that is how you do it. Cool. All right, let's take the antiderivative of tangent. Now I know what you're thinking. Oh, that's probably some rule right there. So let's go ahead and pull out our fancy set of rules from our first video. And let's look for the antiderivative of tangent. Tangent, 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 tangent. Tangent, 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 tangent. It's not there. It's not a rule. Which makes sense because when I take the derivative of any of my functions here, I've never just ended up with just a tangent. I've ended up with a secant tangent, but not just plain old tangent. So gotta do some work here. Don't worry, U sub is at it. So tangent is the same thing as sine over cosine. Okay. Now from here we can go ahead and do a U sub. Now I'm going to let you know when we substitute something out, we're going to need to get rid of this dx and then the other remaining function. Now it's really hard for cosine to be on the bottom and substitute that out. That makes sense, right? So we can't cancel it. It's going to be really hard to cancel a cosine. So since we can't cancel cosine, let's manipulate cosine. So let's let u equal cosine of x. So du is going to equal negative sine of x dx, which I do have that sine dx there. I'm just going to flip that negative on the other side. So now this is going to become negative integral of, well, that cosine on the bottom is a u, and then this is a 1 on top, and that's a du right there. Okay? Now I'm ready to take the antiderivative of this. I know what you're thinking. Oh, just do that reverse power rule. I'll show you something real quick. You can't do the reverse power rule when we have that the exponent is equal to -1. In this case, this exponent is equal to -1. So I'm going to go through my other rules now. Okay, gosh darn it, that's not there. So maybe one of my other rules, will help me out. It's right here. What's 1 over x dx produce? It produces ln, which makes sense because the derivative of ln of x is just 1 over x. Perfect. So this is going to become negative 1 over, no, sorry, not 1 over, 1 over u becomes negative ln of the absolute value of u plus c. And that's just me following my formula. Now u is really cosine. And there you go. The antiderivative of a tangent is negative ln, absolute value of cosine, plus c. You want to memorize that? Be my guest. Anytime you see tangent, you can just pull that off. Or you could just understand how to work it. Either way. Okay, last problem is something called solving the differential equation. Now we're going to have an entire unit over differential equations. To give you a heads up. So this is kind of just like a little mini preview into it and what it's going to be. So what you want to do here for differential equations is get your dy's and dx's on the other side. And that's really the only extra step that we need from what we already know. So we're going to get 9x squared over root 1 plus x cubed plus 5x dx. So now I'm going to take the antiderivative of both sides. So on the left-hand side, I'm just going to get y. Now I would do a plus c, but I'm just going to end up putting the plus c on this side over here if you do not mind. So I'm going to get the antiderivative of 9x squared all over root 1 plus x cubed plus 5x dx. So I haven't worked on that side. Okay. Now, since we're adding these, this one looks really complicated. I'm probably need to do some U-sub. Okay. So what I'm going to end up doing here is I'm just going to end up separating these into two different things. So y is going to equal antiderivative of 9x squared over root 1 plus x cubed plus, don't forget that dx, plus 5x dx. So that way I'm just doing two separate ones. I think it's a little bit easier because this one's going to involve a U-sub. So this middle guy right here, I'm going to kind of just do that one all the way down, and then I'll tag that 5x one just afterwards. So I'm going to let u equal for this one 1 plus x to the third, which is going to give me du equals 3x squared dx. So I need to get rid of my 9x squared dx. Well, I don't really care about the 9 so much. That's not a big deal. So I'm going to divide the 3 over. So it's 1/3 du equals x squared dx. So x squared dx becomes 1/3. Well, that 9 still in front. All over root u du. And again, I'm kind of just ignoring that until the very end. So I'm going to end up getting 3. If I rewrite this, I'm going to end up getting 3 times, over u to the 1/2. I know that's kind of hard to read, so let me just I'm going to finish it up here. So I'm going to get 3 u to the negative 1/2 du, which is going to give me 3 halves u to the 1/2. Nope, 3 over 1/2. Almost got caught there. 3 over 1/2, which is going to end up giving me 6 with my plus c, of course. So 6 square root of, what was my u originally? 1 plus x to the third. Awesome. So now I figured this one out. Now let's go ahead and figure this one out. Antiderivative of 5x is just going to be 5 halves x squared. Awesome. So I have all this side work. So now what I'm going to do is just put everything together. So I'm going to be left with y equals the antiderivative of this. I found out is just going to be 6 root 1 plus x to the third. Plus antiderivative of this is just 5 halves x squared plus my constant, which I do not know yet. And that wraps everything up.